Hey guys, let's figure out some physics together. First things first, here's a circuit. I want to figure out what has more, the resistor or the bulb. It's obviously going to be the bulb, because the bulb's going to get all of the flow. Whereas for the resistors, even though they have less resistance, it splits up to get them. Now if you draw a picture, this becomes pretty self-evident. It's all got to go through the 2R, and then it's got to split in half. So the 2R is going to have more flow than either R's. Now it says to have an equation, so okay. I wrote down the current through the bulb, which is 2R, is going to equal both flows combined. IR plus IR. And then the equation tells the whole story, because the bulb is going to have twice the flow of the individual path. Now for the next one, develop an expression for the voltage drop. Oh boy. Voltage drop is the voltage used. The first thing I'm going to do is I'm going to figure out the total resistance. The R and R are in parallel, so using my equation, I'm going to figure out how much resistance in R and R in parallel are. And you end up getting half R. So if it was like a 10 and a 10, you get 5 ohms. If it was a 4 and 4, you get 2 ohms. So here's my picture. 2R, R over 2, and they're in a series now. Obviously, 2R and R over 2 gets you 2.5 R. That's my total resistance of the circuit. I almost wrote 4 because I'm a poophead. Now, the 2 is going to be it's going to be 4/5 of the total resistance. So to get 4/5 of the total voltage. I'm going to prove this using math in a little bit. Again, since it has 4/5 of the total resistance, 2 over 2/5 of the resistance, it's going to have 2 over 2/5 or 4/5 of the total voltage. Let's say we had a random circuit with a voltage of 10 to 0, and then same ratios, I'm multiplying by 2. You had resistance of 1 and 4. 4 and 1 in series gives you 5 ohms, so 10 equals 5I. I is going to be 2. Doing V equals IR, I get the 4's got 8 volts, the 1's got 2 volts. The 4 has 8/10, which is 4/5 of the total voltage. Now finally, if you remove a resistor, instead of having 2R and R over 2, you have 2R and R, which is 3R. The resistance, you can see, goes up from 2.5 to 3R. So the current's going to go down a little bit, not a gigantic amount because you're just barely going up resistance, but the current goes down. The bulb is going to become dimmer because you're getting less of that flow. But the remaining resistor is going to be brighter because even though there's less overall flow, it gets 100% of it instead of 50% of the little bit higher flow it had before. Bulb gets dimmer, the remaining resistor gets brighter or hotter or whatever. So now let's look at the next one. This one seems really complicated. It says, how do you find the total resistance using which point's voltage to help you out? I'm going to draw a circuit. It goes to the 5, 3, R, and it goes from some high to some low. We don't know what it is. Now to find that resistance, I need to know the current through it. I'm going to call that I2. And I need to know the voltage for it. And I would find the resistance using V equals IR. So right here, I'm kind of like showing the fact that the current I splits up in half. Some is I2, some is I1. Now, if you know I and I1, you could find I2. If you know I1 and I2 and I, you can figure it out. So I'm going to use V equals IR. So look at point A. Between points B and E, that would give me the total voltage for it, but it wouldn't give me the current, so I couldn't find the resistance. So A can't be right. B, if I know that point, the 3, I could find the volts there, but I'll find the current for it, but that's not the same as the current for the other one. So I need to know the other overall current. But knowing the 5, the voltage for the 5, that would give me the total current. I know the other branch, I can figure out the third branch. That's why it's right. For letter C, I'm going to do the same thing. Letter C is going to tell me the total current, and it's going to also tell me the total amount of voltage for it. But the other one will tell me the total voltage of the circuit. So if I know both voltages, I could subtract. Like for example, if it was 10 and 6, I know the voltage for that branch is going to be 4. And if I know the total current, I can now figure out everything else. So it's got to be C. Because those allow me by process elimination to figure out what I2 is and the voltage used by that. This one's not too bad. 2 waves. Which one's higher pitch, which one's louder? Louder is how amplitude it is, like how tall it is, which obviously oscilloscope 1 has a larger amplitude. Also, oscilloscope 1 is closer together, so it's more frequent. So oscilloscope 2 is a low pitch, 1's a higher pitch. And the only answer that has that is going to be letter C. Now, take a look at the last one. Pretty much it says you look after these have passed each other by a third of a wave. So watch as I break this down. The first thing I'm going to do is I'm going to kind of figure out how much of that wave is a third. Draw a straight line. So I kind of like those points represent each a third of the wave. So I'm going to draw it in. So point P would be at that point right there after a third. So there's that part, and then after point P is to be that part of the left-hand wave. That shows that point P is after a third. And for the other one, I kind of draw too many dots. I'm sorry, so I redrew the dots and drew the lines there. It's kind of like point B is that point I'm pointing at right there. So there's a down and up afterward. You can see how those points overlap. Then afterward, I go up, down, up, down, up, down, up, down. So you can see what's going to happen. Point P is still 0 because there's nothing there. But then afterward, both parts add. So you get 2A down. Then they go up for another 2A. And then they go A and A. My picture sucks, I know. The other side, both things add. So you get 2A. Then down to 2A. A and A. So there we are. Yeah, I know, it's bad. My bad. Because you can see they overlap so that even the point P cancels out. To the left and right, there's going to be part of a wave overlapping. Now, the next question asks, what is actually point P's displacement over time? In other words, how much does it go up or down at each moment? Well, you can see how these things are perfectly opposite. Point P will never move. So it's always going to be 0. The points will always cancel out. Finally, now, next, the oscillators make a continuous wave, so that way it's make a full wave. It's not going to change. But it's got to have a start point and end point. So the endpoints here are fixed. And since they're fixed on a string, the endpoints have to be nodes. So since this is a string, it's got to end at a node to a node. So looking at this, I drew a little example. That could be an example. That could be an example, and so forth. So it's got to go from a node to a node. So what's the equations? The wave could be half a wave, because that'd be from node to node, or one full wave.